Hello, Mike Test. Good afternoon. So, good afternoon. We go now to the block diagram simplification, and it is a seat work or it is some kind of exercise during the class. So, there are three problems given to us, and these are the problems or the diagram that we need to simplify. So, this one, first, we have this block diagram or block transfer blocks in uh, in series, and then there's a parallel. So this one is in series, and this one is parallel to this, right? This one is there's a two summing junction. So we need to simplify first this. Diba? Once we simplify this, then it's going to be in series. For example, if we simplify this with a one block diagram, then this one and this one are just arranged in series. Then we can multiply uh, one with it with the other, and then there's feedback here. It is the H. Okay, so here, how do we attack this? I think it's better to simplify this first. Then if you simplify this, because there's a feedback block or loop, then we can put it here. They are arranged in series, and then it is arranged in parallel or this feedback. Okay, so these are the answers: A, then B, and then C. Okay, okay. So we start with the first. We start with the first one. So how do we do that? So here is the solution. So these are arranged in series. These two blocks are arranged in series. So what we have to do is we just have to multiply, right? So 1 over S, then 1 over S plus 2. Okay, so it's like this. Yeah. So this one, we can algebraically, we can simplify 1 times 1, then S times S is S squared, then S times 2 is it correct? S times 2, 2S, right? So this is the equivalent. And then we're gonna put that simplified block diagram of the forward loop to the original block diagram. So we just have to copy this. So 1 is the numerator, and this one is S squared plus 2S. So there's a signal here, and then there's a block diagram in the block in the feedback loop. Okay. So how do we simplify this? So we have this numerator, feed forward, and the so-called feedback. No, so this is G, this is H. Okay. So what is our format. Our format is with this kind of diagram, we have to copy the G, which is this whole thing, and one, then we have to see the sign. If it is negative, just the inverse, so it's going to be positive. Then GH, no. So the G is this, then the H is this, right? So H. So let us do that. Let me put a vertical line here. Okay. So we're gonna do that with another color. So first thing first, G. So the G is this whole thing. So we're gonna copy that, right? 1 over S squared plus 2S. Okay? 1 over S squared plus 2S. Then we're gonna execute this. 1 plus G. So the whole thing here is G. 1 over S squared plus 2S. So this is the G. Then the H is the 2. So the H is this 2. Okay? So the G is here and the H is here. 1 plus, so this one, 1 plus. Okay? So how do we simplify this? As you can see, there is this, so there is this denominator, and the denominator is S squared plus 2S. So we need, what we ought to do is this, right? So we're going to multiply this with the same expression with the numerator and the denominator, and that is S squared plus 2S. So this one here also, because this is the bar line that separates the numerator and the denominator. So we're going to put also S squared plus 2S. Oh, sorry, plus 2S here. Okay. Okay. So this and this are just the same. No, it's just the same. So it's like equivalent to 1. And if you multiply the mathematical expression with 1, as if you did nothing, because multiplied by 1 is itself. Now that will result to the original. So what we're gonna do is to put it here. So cancelled, no? S squared plus 2S, 1, right? So the whole numerator will become 1, right? And then we're gonna distribute this because it is separated by a plus sign. So we're gonna multiply that here, and then we're gonna multiply this expression with this. Okay, so let us do that. So S squared plus 2S times 1. So S squared plus 2S. This one here. Then here, S squared plus 2S. No? So it's going to be cancelled. Then we retain the 1 and 2. No? So 1 times 2 is just 2. Okay? So 1 over S squared plus 2S. S squared plus 2S plus 2. Yeah? So if we factor this out, 1, for example, if we take out S, to achieve S squared, we put S here, and to achieve 2S, we put 2, right? For example, if we want to separate the S, so S squared, this one, S times S, then I mean 2S is S times 2, then plus 2. Okay, so we'll put a bracket here. Okay, so that's gonna be the final answer. So let me emphasize by putting a circle here. Now, 1, 1. S times S plus 2. S multiplied by S plus 2. Then plus 2. Okay, so that's the solution for the first problem. So next is this, B. So how do we solve B? We can solve B, or this problem B, with this. This is the answer. So this one, now, intuitively, we should simplify this. Okay? So to eliminate the summing junction symbol, okay? After this, now it will become one block. Then it is in series with this. We just have to multiply. Then it is in parallel now. So this whole thing is in parallel with this. So we have to use the standard feedback simplification. Okay, so we start. We're gonna use this. So this one is unity feedback loop. Okay, it's one. One. Okay, so the standard form for feedback simplification is this: G forward loop, then 1 depends on the sign here. If it's negative, it becomes positive. So 1 plus G H. But G is this, right? K over S minus 1. And H is 1. Okay? So we're going to do that here, at the bottom. So it is K over S minus 1, which is this. Then we put the bar line, or upon, no, or divided by, no, 1. Then look at the sign. If it's negative, that's the reverse, positive, right? So this one, positive. What about G? So this is the G. So we're going to copy this. K, S, minus 1. What about the H? So this is the H, right? So 1 only. Okay. So can we simplify this still? We can, right? Because we have to multiply both the numerator and denominator with expression that will eliminate the denominator of each element. And that's going to be what? Let me change the color. This one, no? So we multiply this whole term in the numerator with S minus 1, and also this with S minus 1. So S minus 1 divided by S minus 1, like 1 divided by 1, or 5 divided by 5, will yield to only 1, no? So as if you did nothing, because you multiplied both the numerator and denominator, and that makes it balance. And it's like S minus 1 over S minus 1 is just 1. But you can simplify this, right? So S minus 1, S minus 1, so that will be cancelled. So this numerator becomes K. And this one, no, this becomes distributive um, property application. So there's a distributive property that you have to multiply the term for each term when it is separated by plus or minus, right? So this one you have to multiply, and for this you have to multiply. So s minus 1 times 1, s minus 1 times 1, right? S minus 1 times 1, okay? And here, s minus 1 will be cancelled, right? Cancelled. So what will be left is k times 1. So here, it is separated by a plus sign. So plus k. So did we miss something? So s minus 1 cancelled, s minus 1 is cancelled. So this one is s minus 1 plus k. Okay? So s minus 1 plus k. So this one becomes right, like this. K s minus 1 plus k. Okay? So this thing here, we have to substitute here. Okay? So we're going to do that. Okay? From the original expression, it becomes like this. So there's a summing junction, and there's a signal which is positive. Then there's a block here, 1 over s. Then this whole thing now becomes this, right? So we're going to do that because we already eliminated the summing junction, right? So this one is k over s minus 1 plus k, and there's the signal here, and then there's feedback here, right? So the sign of this is negative, okay? So now all we have to do is to multiply this, right? Because they are in series. If they are arranged in series, then we have to multiply, okay? And then here is the feedback. So this one is G, the whole thing is G, then this is the H, okay? So let us do that. Let me copy this so that we are not going to rewrite the whole thing again. Okay, so we're gonna put here. Okay, so this, they are arranged in series, so we just have can just have multiply this. So this one is 1 over s k now. So 1 times k is k. Then at the denominator part, s times s minus 1 plus k, right? Correct? So here, then here, uh, we just have to simplify first this one. So this one is k, then s squared, s times s, then s times negative 1 is negative s, then S times K is Ks, right? Plus Ks. Okay? So this whole thing is this, right? So we're gonna put that here. So there's a summing junction and there's a signal here. Then it's gonna be positive, and then there's a feed forward here, and then there's a feedback loop here. S plus 2. Okay. So this is it. K over S squared minus S plus Ks over S plus 2. So this becomes G right now. So this whole thing becomes G. This is the H. Okay. So our standard form for uh, feedback loop simplification is this. So G, which is the forward loop, 1, then look at the sign here. I think this negative, right? So if it's negative, it's the positive, right? Is it positive, negative? So if it's negative, you put positive here. Then G times H. Okay? So what will happen is this, right? So G, which is K over S squared minus S plus Ks divided by 1 plus G, which is K over S squared minus S plus Ks, right? G. Then times H, which is S plus 2. Okay? So how do we simplify this? So we see this S squared minus S plus Ks and here, right? So we are going to multiply that with the numerator and the denominator so that we can eliminate that expression. So we're going to copy this. We're going to put it here. We're going to put it here. Okay. So what's going to happen is this. So we are going to multiply, no, this numerator and denominator with this. Yeah. S squared minus S plus Ks. Okay. Over 1. Then this one also S squared plus, sorry, minus S plus Ks over 1. Yeah. So this one now is the same, right? So this one and this one is the same. So if you divide in mathematics a variable or an element, a value that is the same with itself, now it will just result to 1. So it's as if you did nothing. But what we can simplify the system with this. Now, so this one is in the denominator. This one is in the numerator. So we can cancel this out. What will be left is K. So what will be left is K. So let me put this. So here is this. So in the numerator side, it's going to be K only, right? K. So this one, because this one and this one canceled out. Then here, we're going to multiply this with this 1 and then multiply this with this term now, right? Okay, so we're gonna do that. So s squared minus s plus ks multiplied by 1 is itself, right? S squared minus s plus ks multiplied by 1 is this now. S squared minus s plus ks times k over s squared minus s plus ks. So this term will be cancelled out, right? So what will be left is k and then s plus 2. Okay, so k, it is separated by plus, so we affix that. Then k s plus 2, k, and then this one is in the numerator. S plus 2, okay? So k s plus 2, okay? So when we simplify this, so this one is going to be k, then this one is s squared minus s plus ks, then plus k s plus 2, okay? Can we simplify this further, or not? I think, mm, I think we can, but I think that's enough, right? So this is the answer, right? K over S. Let me copy this. So the answer is this. Let me compare. So K, we have a K, K. Then S squared minus S plus K. Okay, so we can simplify this just to separate the S, no? So we factor out S, no, from the three term. So we take out S in order to get S squared. Then minus S is minus 1. Then plus K. S minus S1. Yeah. So plus uh, K. S squared minus S. Then plus K. Or just the ks. Now we can separate this, right? So s squared minus 1 plus, then we retain this plus k s plus 2, then we affix this. Okay, so why is that put like that? Because we are in the descending, right? Descending order of exponent or degree, no? So degree or order in differential equation, right? So this is s cubed, but we take out the s, so s squared, then s, no, s, then just the ks, right? So s, k is k there, then s, quantity s minus 1 is 1, right? S, right? S minus 1, so we don't we don't need this anymore now. So s minus, because this one is s squared, right? So s minus 1, this one, s minus 1, plus k quantity s minus 2, k quantity plus 2, then plus ks plus ks. So correct. Okay. So we have uh accomplish the number 2 or set B. So we go now to number 3. Yes. Okay. So the number 3 is this. So how do we simplify that? No. So first, we're going to simplify this term here to eliminate the summing junction. We cannot just simplify this because it is attached with this feedback loop, right? So we need to simplify this to eliminate the summing junctions. And how do we do that? No. So we're gonna copy this. The standard format is G over, look at the sign. If it's negative, then just the reverse. 1 plus GH. But what is G? Diba? Where G is what? 2 over S plus 1 and H is 4, right? So continue here. So we're going to follow this format. So G is 2S plus 1, 2S plus 1 over 1 plus, no, 1 plus G. So we're going to copy this, 2S plus 1. Then H. H is here, 4. So it has a multiple feedback, right? So 4 is this, right? So we're going to simplify this first, and then it becomes 1. Then that is going to be arranged in series. We have to multiply, and then we're going to use the feedback loop transformation because there's another feedback here, the 3. Okay, so how do we simplify this then? Okay, so we can simplify this. Let me pull out different of color. So this one, you can see we can multiply this with s plus 1. Here is s plus 1. So if you divide same value, no, or same element, it will result to 1 only, as if you did nothing because you just multiply this one by 1. But we can substitute this, or we can simplify this now with this. So s plus 1, s plus 1 will be cancelled. So this is going to be 2. Then here, s plus 1, right? S plus 1, you have to multiply this with this and multiply this with it, right? So when you multiply s plus 1 with 1, so it's going to be s plus 1, right? But this one, if you multiply this with this whole thing, right? So this whole thing here with the black circle, s plus 1, s plus 1. So that's going to be cancelled out. What will remain is 2 and 4, which is 8. So s plus 1 here, s plus 1, then separated by plus sign, plus. Then cancelled out. 2 times 4 is 8, right? 2 times 4 is 8. Okay? So this becomes 2 over s plus 1 plus 8. Okay? So this the result here will be put here, right? So let us do that. So there's a summing junction, and we were able to eliminate the summing junction at the middle, which is this one, right? So this one. So now it becomes what? This one, this whole block here is this, right? 2 over s plus 1 plus 8. But there's another block here. Uh, so we're going to affix that. 1 over s. Then there's a forward signal, and then there's here a feedback because we were able to eliminate this already. Then there's a feedback here, feedback loop, which is 3. Okay, so these two are arranged in what? In series. So if they are arranged in series, we have to just get the product or multiply, multiply. Yeah. So we're gonna multiply this and then execute the standard form for the feedback simplification. So we're gonna copy this and then put it here now. So we continue 2 over s plus 1 plus 8 times s. So we just have to multiply 2 times 1, 2 times 1 is 2. Then s plus 1 plus 8 times s. So s plus 1 plus 8, right? 2 times 1 is 2. S plus 1 plus 8 times s is this. We're going to enclose this in just one block or rectangle, right? Then we're going to copy this. So that has a positive signal, then this is negative. Okay, so that is the simplified version. Okay, so we're gonna label this thing. So this thing is G, no? This whole thing is G, and this is H. Okay, so we can simplify that here on the right side. So by just following this G or the feed forward loop, one, like take a look at this and get the reverse or the inverse. So if it's negative, you put positive here and then GH. So what is G? This is G. What is H? 3, right? So we're gonna write here 2 over S S plus 1 plus 8, right? So that is G, right? That is G over, this is the line, 1 plus G. So what is G? 2 over S S plus 1 plus 8. So that's G. Then H, what is H? 3. You multiply that by 3, right? Now, we go now to the simplification, and the question is, what is the expression that we're going to multiply to both numerator and denominator that will simplify the expression? So we're gonna choose this, right? S plus 1 plus 8. Okay, so if we multiply the numerator with this S plus 1 plus 8, and also the denominator with this, right? So S plus 1 plus 8. Okay. So simply we can eliminate this because one is in the numerator and the other is in the denominator. So they are the same. So it will be equal to 1. And we don't normally put 1 here. Now it's understood that that's 1. So 2 times 1 is just 2. So what remains here is 2, right? So in the denominator, let me put here 2. Then here, we have to multiply the whole term with this, right? We multiply this with 1, and then we're going to multiply this here, okay? So S quantity S plus 1 plus 8 times 1 is this, right? Then if you multiply this whole term with this S plus quantity S plus 1 plus 8, so that will be cancelled out. What will remain is this. Now 2 times 3. 2 times 3, right? So here is this. Now, so 2, then in the numerator, and then this the overall um, division sign. Then S plus 1 plus 8 here. And then if you multiply with this, S plus 8, this will be cancelled, this will be cancelled. So 2 and 3, right? So it's like plus 2 times 3 because there's a sign here plus, right? Okay, so we're gonna copy this from here and then we'll continue. Okay, so let me pull out a block. Yeah. So what do we make of this? So this one is 2, right? So this one is 2 over what? S squared plus S plus 8S. So, right? This whole thing. S squared plus S plus 8S, right? Then it is separated by plus sign, so plus 6. Is that the 6? Plus 6, right? 2, 2 times 3, okay? Is it 2 times 3? 2 times 3 is 6, okay? So here, plus 6. So let me arrange this, right? So this is going to be 2s squared plus 8s plus s plus 6. So here is 2. 8s plus s is 9s, right? So s squared plus 9s plus 6. Okay? So I think this is the overall or the final transfer function. 2s squared plus 9s plus 6. So let me 2, yeah, 2 over s squared plus 9s plus 6. Okay, so it's just the same with this s squared plus 9s plus 6. Okay, so that's the last problem, which is the number 3 or set C of uh, second set. So I hope you learned something in this block diagram simplification, and later we're gonna continue with more complicated samples. Thank you very much and have a good day.